Okay, I've just chosen a few problems to kind of highlight on the review sheet to explain actually just some parts to some problems without going through the entire problem. I wanted to focus and make sure that everyone was feeling all right with how to tell whether there are no triangles, only one triangle, or two possible triangles that could be made with the given information. Okay, and so I'm just going to kind of talk through how to get that far and assume that you guys will be okay with using the law of signs to help you find all the missing pieces to any of the triangles that do exist. Okay, it is virtually impossible to tell just from the given information whether you're going to have 0, 1, or 2 triangles possible. You have to just kind of jump into the problem, and from there it kind of unfolds. So first and foremost, you need to take the information you're given, you need to draw a picture, and you need to put that information onto the picture, and I've already done that for number 2. Okay, after that, we're looking for a strong ratio. We can see here that we have a strong ratio where we know the angle, we know the side opposite that angle, and so we have no choice but to try to find angle A first because we're given side A. Okay, so we're going to go ahead. This would be the natural starting point for anyone who would do this problem. Okay, we're going to go ahead and cross multiply. Okay, and so we just kind of keep progressing through here. We're looking to get sine of A by itself, and then to break the sine away, we do the inverse trig function in order to get just angle A by itself. Okay, when you do that, initially, you're going to end up getting roughly 21 degrees for angle A. Okay, so if we put 21 degrees in here for angle A, this is when you are going to, first and foremost, we can say, well, we can definitely eliminate, we know the answer is not, there are no triangles possible, because anytime that is your answer, it's when you type this into your calculator, you get an error. And we didn't get an error. We got an answer, 21 degrees. So the question is this the only triangle, the one I have drawn here, that's possible? Or is there actually a second triangle that's possible? Okay, and so I'm going to go ahead and just draw a second triangle. I'm going to go ahead and place the 3 given pieces of information onto that triangle. Okay, and then I'm going to take the angle 21 degrees that I originally got for angle A. But if there is a second triangle, angle A would be the supplementary angle to that. So 180 minus 21, angle A would have to be 159 degrees if there is a second triangle. And so we look at this second triangle that I have drawn here and we say to ourselves, is this even possible? Could angle C be 118? And could angle A be 159, all in the same triangle? And the answer is no, because those two angles add up to 277 degrees, and we haven't even accounted for angle B. We know there's 180 degrees in every triangle, so that eliminates that option. That means I would circle there is only one possible triangle, and then I would come back over here to my problem. It looks like I've got some blanks here. I had this other set of blanks in case there was a second triangle possible. I'm going to cross those off because there's not. Okay, I do want you to continue to add the pieces of information as you find them onto the picture, but you can also fill in the blanks down here as well. Okay, and this is all the farther I'm going to take you through problem number 2, because I'm going to assume that you would be just fine finding angle B and then doing another law of signs situation to come up with side B. Okay, now let's go ahead and take a look at example 3. Okay, here I have the picture drawn for you. Again, very difficult to tell whether we're going to say 0, 1, or 2 possible triangles until we actually get into the meat of the problem here. Okay, I see my strong ratio, sine 25 degrees over 15. I need to find angle C first, so I'm going to put sine of angle C over 18. I'm going to go ahead and cross multiply here. Okay. And then we would divide by 15, and then we would do the inverse sine of both sides. Okay, now keep in mind, if we get an error, then I'm saying there's no triangles possible. I'm done with the problem. I can't find all these missing pieces if there's no way for the triangle to exist. I think in this particular situation, I end up getting angle C to be 30 degrees. So I'm going to fill that down here on the blank. I'm going to go ahead and add that into the picture. Okay, and then I am immediately going to come over here, draw a second triangle, again with the given pieces of information on it. And then I'm going to say, well, if my angle C was 30 degrees there, then that means if there is a second triangle, angle C would have to be 150 degrees over here. So then I say, well, is that possible? Can angle C be 150 and angle A be 25 and these still coexist in the same triangle? Well, sure, I don't think that goes over 180. Wouldn't these two angles add up to 175? And that would give me an extra 5 degrees left over for angle B. So in this particular problem, I'm going to go ahead and come up here and I'm going to circle that there are two possible triangles, and then you basically have two problems in one, where we're just going to I'm going to splice the paper sort of in half here. We could come back to the first triangle and do the same thing and say that if we have 30 and 25, that adds up to 55, so that means angle B would have to be 125 degrees. I'm going to throw that on the picture. And again, I'm going to assume from here that you guys would be just fine finding side B in this triangle and side B in this triangle by just setting up a law of sines situation for each of those to come up with those sides. Okay, so we've talked through how does it look when there's only one triangle. We see, oh, that's too many degrees for one triangle, so we know there's only one triangle for that, not two. Okay, here we see, okay, well, this would work out just fine, so that's why there's two. Okay, let's take a look at this one, number 4. Okay, number 4, I see my strong ratio here, so I'm going to start there. I got sine of 70 over 5. I'm going to do sine of C over 16. Cross multiply here. Whoops. Do this part first here. Okay, divide by 5. Inverse sine of both sides. And when I do inverse sine of both sides, I can see here that the measurement of angle C, now here's where on the calculator, I am getting an error. Okay, so when you get an error, that's telling you there are no triangles that you could construct. If you were physically going to measure this out and make a triangle using, pieces of string or pieces of a straw, that would have a 70-degree angle here, that this side here could be 16 units, and this side over here would be 5 units. So we just kind of stop there with the problem. We don't fill in any of these blanks or anything more to the picture. Okay, there's one other one that I want to look at with you. It's number 6 on the back. You can see that on number 6, it's not really telling you when you have to use the law of sines or the law of cosines. I don't know if you guys have picked up on that. You always want to err on the side of law of sines if you can, because it's easier. So look for those strong ratios where you know an angle and you know the side opposite that angle. Here's the situations where you're going to be forced to use law of cosines. In number 6, you're given side, side, side. We know nothing about any of the 3 angles, therefore we do not know, we don't have a strong ratio, okay? The other situation where I believe that this happens for when you have to use law of cosines is also the situation side, angle, side. Okay, that your hand's kind of forced to use law of cosines. So I'm just going to jot down over here. Here is the formula for law of cosines. Of course, we can write it a variety of ways depending on which angle or which side you're trying to find. But the key is whatever side is squared all the way on the left, that is the angle that's being used all the way on the right. Okay. Okay. Now, the other very important component is when this is asking you to solve the triangle, it is in fact asking you to find all the missing pieces, and we know that we would want to find all three angles. The order you find these does matter. Okay, so you need to find the largest angle first, which is obviously going to be opposite the largest side. So we are going to find angle B first. Okay, the only place in law of cosines for you to put an angle is right here in this spot. Okay, and whatever angle you put in that spot, all the way on this side has to be that opposite side squared. So if I'm looking to find angle B, I have to, on this side, take side B and square it. That would be the 21 squared. Okay, and then what gets filled in the middle are the other two sides. Okay, so the other two sides squared and added together. So that would be, in this example, the 16 squared plus the 15 squared, and then be careful, it's a sign change here, minus 2 times those same two sides. In this case, 15 times 16. Okay, so what we're going to do next is let's square off these numbers. Okay, the mistake that I often see a lot of people make is they try to type all of these numbers in at once, and you run into trouble because this minus 2 times 16 times 15, that is attached to this cosine B. It is a completely separate term, so you need to be very, very careful there. Let's see, we got 16 squared and then 15 squared, so that's going to be 256 and 225, and then 2 times 15 times 16, that ends up being 480. Okay, now you can combine these two numbers together, the 256 and the 225, that's okay. Okay, but what you cannot do is you can't take 481 minus 480 and say that there's a 1 in front of this cosine B. Okay, order of operation, these are two completely separate terms. This and then this is all chunked together, okay? So be very, very careful about that. So what you're after here is you are after trying to get this cosine B by itself, okay? So I'm going to subtract 481 from the right side, okay? So we're going to subtract 481. That's going to give us negative 40 on the left. Okay, then to get the cosine B by itself, we're dividing by negative 480. Okay, do not write down decimals, please. Okay, switch that back into a fraction. It switches into the fraction 1/12. And then here we are going to get rid of that cosine by doing the inverse cosine of both sides. Okay, this is going to tell me that angle B, inverse cosine of 1/12, if I round that up to the nearest degree, is roughly 85 degrees. So I'm going to put that down here on the line. I'm also going to put that up here in the picture. And then I should be good to go with, now that I have a strong ratio, I can continue with this problem and I can set up law of sines, okay, which I'm going to trust that you would be okay with finishing this problem. I will tell you the next angle you find, though, needs to be the next largest angle. Okay, so we found the largest angle first. The next largest angle would then be angle C, okay, because that's opposite the next largest side. Okay, and then you just keep progressing through, cross multiplying, doing the inverse sine. And when you get that angle filled in, we know these add up to 180. So the last angle A should be very, very easy. Okay. All right. If you have any further questions, you want more explained, please just reach out. The test is tomorrow. Okay, it should not take any longer than about 45 minutes. And you'll have from 8 a.m. to 8 p.m. to complete that.